Particle physics is the most fundamental branch of science. It studies the base of everything. Interactions, properties, and behaviors of particles are what ultimately govern the universe. Let's take the atom. During your very first day learning about chemistry in high school, they'll tell you that atoms are composed of electrons, neutrons, and protons, but they won't really give you much of a background, which can make chemistry seem very out of context. Particle physics is the context you may be looking for. Here's something called the Standard Model. The Standard Model is to particle physics as the periodic table is to chemistry. Right over here, you'll see the ordinary electron. This is the type they talk about in chemistry. There are two other, more heavy types of electrons called the muon electron and the tau electron, but these are not very common because fundamental particles naturally decay to the smallest mass possible. The tau electron is heaviest and is said to belong to the third generation. The muon is medium and is said to belong to the second generation. Now let's talk about protons and neutrons. Protons and neutrons are composed of up and down quarks. Notice up and down quarks are in the same column as the ordinary electron. The first three columns represent the three generations. The first column is the first generation, or the smallest weight. A proton has a charge of +1. Up quarks have a charge of +2/3, and down quarks have a charge of -1/3. So a proton is made up of 2 ups and 1 down, because 2/3 + 2/3 -1/3 is 1. Neutrons have a charge of 0. They're made of 1 up and 2 downs. 2/3 -1/3 -1/3 is 0. If we look to the column right of the third generation particles, we'll see a column in blue. These are called the gauge bosons, which are responsible for 3 of the fundamental forces. Photons are associated with electromagnetism, gluons are associated with something called nuclear force or strong interaction, and the 2 bottom bosons, the Z boson and the W plus or the W minus boson, are both associated with something called weak interaction. Weak interaction is a process that a proton can undergo to change into a neutron, or vice versa. This process is the very reason there's life on Earth. It's what happens inside of the sun. In the center of a star, hydrogen atoms become so energized that the electron actually leaves the nucleus, leaving behind only a proton. All it takes to change a proton into a neutron is to change one of the up quarks into a down quark. Because the total charge involved in this reaction must be conserved, protons can't just turn into neutrons without anything else happening. So to balance the energy and the charge involved, 2 other particles happen to be created, the positron and the neutrino. Neutrinos actually leave the sun and travel really quickly out into space. The thing about neutrinos is that they rarely interact with anything they pass through. There are billions of neutrinos passing through you this very instant, not affecting you in any way. They'll just make their way through the Earth and continue on their journey into outer space. Positrons are something called an antiparticle. They're the antiparticle of the electron. I won't go into much depth about antimatter, but basically every particle has an antiparticle. They're almost identical to the normal particle, but the one difference is that they have the opposite charge. Since the positron is the antiparticle of the electron, a positron has a charge of +1. But antiparticles are very rare. They typically don't even exist for a second. Usually they'll hit some normal matter and turn into energy with it.